So I propose to set up a plan. What are we going to speak about? What is most interesting to you and what we speakers can bring to you as valuable information? So first input was that everybody uses service mesh. And from that point of view, let's first, do you agree with me that first would be nice to give input that what really service mesh is from an abstract point of view? Why we can say that, do we really use it everywhere? Do we have service mesh everywhere? What is it? And where really we do have it and where it just doesn't exist? And when should we come to a solution that we call service mesh and when not? So what are the cases that we can use it and what are the cases when we should not do things like that? Would you like to add something to this plan? If you need mic, we have a second. Okay, so first of all, what is service mesh from my point of view? And you can argue with me, you can add more information, you can say that I'm wrong in some directions by saying some thoughts of mine, so it's fine. Let's just find the truth. So service mesh from technical point of view, it's some kind of technical solution that allows us to replace many of network-related activities, that the boilerplate that we do in microservice applications, in the code, so that, well, I would say from my point of view, we have understanding of what DevOps is, and in microservice systems, DevOps really played one of the key roles. But again, it was just Pareto rule, like 80% versus 20%, so 80% was really done by developers, that was the thought. And with appearance of service mesh, for me, it split it 50-50. So that developers do the business logic. Well, for me, it sounds like they can do only business logic or almost mostly business logic. So that DevOps can do the rest half, which is also part of the development of the system, but is more about infrastructure, how components are working together, maybe not only infrastructure, but what is related mostly to handling of cases related to network, to metrics, to logging and other stuff. So like things we did in code using some ready out of the box components like circuit breaking, load balancing and other stuff. Now we say that we can decouple the things so that instead of developing a huge service, we develop service template, which is just business logic plus some smaller things that we need to connect it to all other connectors. And all other connectors are provided by service mesh, which is about circuit breaking, about load balancing, about sometimes authentication, metrics, all this stuff. And the solutions that we use for that, for me, well, it is, I would say, for me in my projects, up to this moment, it is still maximum release candidate. I didn't have a project where we have service mesh at a point we can call it production. It may be production ready for someone, but again, it's something what is in development up to this moment. Many of features we would like to see or we would like to have are in release candidate or even in plans for development with Istio, with other Linkerd or other components that we call service mesh implementations. And I would like to hear also your thoughts, guys, before we go forward. Where do you use that? Where have you, what components really have you had chance to play with, maybe?
Yeah, let me start by also doing this kind of leverage about Istio. I would say that they use, not as specifically Istio, but as related to service mesh. We are in a Java conference, so I believe that all of us here are Java developers. So when we say that it's split at 50%, which is true, it also gave us another capacity, which is when we are talking about microservices, we are not only talking about Java applications, because there are different teams that can use Java, Python, Go, PHP, different languages. So different languages should have a moment in time before Service Mesh where they needed a library to implement circuit breakers, retry, resilience, tracing, everything else. So it's not only about having giving the developer the opportunity to focus only on API and letting the operators taking care about the traffic, but also allowing different languages to have the same functionality implemented by the container, by something else. It's still having the developer is still focus on API. So we are Java guys. We will focus on the Java API. The Node guy will focus on Node APIs. But
they will also focus on fixing JavaScript bugs.
Yeah. The same is true also for the Go developer. But the thing is, those features provided in Service Mesh will be available to any language.
Well, I just wanted to add one small thing. You speak about different languages, and from just personal point of view, when I overview Service Mesh as a solution for for fixing some things, let's say, which I oversee in the architecture, I consider two kinds of projects. For example, smaller projects, my pet projects, or projects that we do with other guys, like some small home project which we would like to grow as a startup, and bigger projects, enterprise level projects that we do at work, for example. And I see also different types of power that you need, the force you need to drive those projects. So in smaller projects, up to this moment, I would consider Service Mesh a more, like, it's a power up, but it requires more knowledge, more hands that can work with it. So I would say in bigger projects, when we have more people in-house that can do things like tens or even hundreds of developers, for me, I would consider it as a maybe better solution because of abstraction level. As you said, we have many languages, we have many options, and we can build a distributed application. I would call it that way. Doesn't matter if you call it microservice or anything else, call whatever you want. So a distributed kind of application with many of components, and we should make them be friends between each other, reusing API and other stuff. But in smaller project, it's more kind of additional layer that I had to take care of, but maybe I don't have enough resources for that. And for me, again, I would say it's not a single solution for all the problems, but it's an option that I would consider when I will do the architecture of a project, depending on some requirements or depending on the nature of the project. So if it's a bigger or smaller, or maybe you guys can ask questions or add more information about in what kind of other criteria for picking the right solution.
You know, there is a saying that's from a humorist that says that marriage is a great way to solve problems that you would never have had if you didn't marry in the first place. And Service Mesh is exactly the same. So it's a great solution that can help you solving the problems that you created by using a microservices architecture. The question is, do you need it in the first place?
So as for me, I think that one issue that stops adopting Service Mesh also is poor incremental applying of Service Mesh. So for now, for example, if you're using Istio, you just install all the components of the Istio, but on the existing project you could already have a circuit breaker, you could already have some retries, and for example you need only telemetry. And poor incremental update is one issue that stops adopting service mesh in most of the projects, as for me.
Yeah. Maybe we go a little bit into technical details. Do you guys, do we have anyone here who knows how service mesh works? Okay, can you tell us? Because we don't know.
Yeah, so as far as know about service mesh architecture, so the main idea is to have a sidecar proxy which proxies the traffic to the service, and using it you can like do lots of stuff, you know, like gather logs, like redirect traffic to.
Yes, it is. So in simple words, we consider another proxy, which we call sidecar, which always is here near your service or in your, let's say, per host. Just an example. So per service, per container, per host, per pod if you use Kubernetes. So what is it? So you have a proxy server which does all these stuff, which we call like infrastructure or not business logic related things. And your service, and near it, the sidecar. So it's 50% here, the business logic, and 50% here of other things that you can do in a proxy, which may be programmable proxy, or which may be just simply adjustable with some configurations. And the simplest service mesh is, it's called data plane, when everything related to data, the APIs, the things that the payload which is sent between services, am I right? So we call it the data layer, and we have a control layer which can be a command line instrumentation or a web UI for administrating all these service mesh proxies, where you input the settings, they go to your cluster, so that all the proxies near all the services know what they should do per each service. Now you have the data layer, where your code, the business logic works, split it into services. You have the proxy servers, which we call sidecars, and the control layer, which is responsible for putting in the settings for proxy layer. Like, would you like to add something here? Because I tried to maximum abstract it, maximum simplify. Is it clear enough, or maybe somebody who didn't work with it have questions? Okay, so let's consider it's clear. So we have a proxy, which is controlled through your administration layer, and you have all services that provide data to each other so that the application works. And we just use this proxy layer. And in most architectures, this proxy layer also can be pluggable. For example, in Istio you have, am I right, is it Envoy as default? And you can change it even to, I think Nginx also has a solution for Istio where you can get simple Nginx and use it as proxy, as a sidecar, or any other. I think there was also a kind of a solution with Linkerd first version or second, I don't remember, which could also be paired with Istio. I may be wrong here, actually. So technically, it's just a bunch of proxies sitting nearby your services. And the boundaries are whatever you would like to be. Like, you can deploy a few containers with a few services on one host and have single proxy per host. Or you can configure it having proxy per each container, for example. So a service mesh is a bunch of resources which you actually could be wasting. You have computing power which you may be losing just because you use service mesh. What if I ask this question? Isn't it a solution that wastes our resources?
Do you mean because you have a proxy that's always on and it's...
Yes. and we have many of them all over the cluster.
In case of Envoy, I would say that's the resource consumption is really small because it was implemented using Envoy was implemented using C, so it's very fast and plus it's very lightweight. So I don't have the numbers at this moment, but I know I can't say how much CPU or memory it consumes, but I would say that for a matter of traffic, it almost doesn't impact at all because of the nature of the implementation. Although it handles the layer 7, the application layer of the traffic, it handles very, very fast. I just really don't know regarding the memory and CPU consumption.
But from the pattern-wise, I mean, we liked, for example, I liked the idea having microservices with all of the client-side kind of patterns, like client-side discovery, client-side load balancing, and other stuff that really helped me to get rid of proxies that I have to deploy and support. But now with service mesh, again, the idea of server-side implementations through additional proxy layer again comes back. So isn't it a step backward? I know, I see that smile.
No, because I mean, if you look at the history of computer software, it's always going left, left, right, left, right, and it's never thinking in the middle or whatever. It's one extreme to the other. I mean, you saw how the business logic before was in mainframe, and then it went to the personal computer, and now afterwards it was like client server, so it went back to the server, and afterwards it was rich client, and I mean, so I don't see it in a term of backward and forward. It's just like back and forth shifting all the time.
Yeah. So we use thick clients, but we call them rich clients.
It's interesting to see when we recap the history of computer science and software development that between these switches we always gain something, because nowadays we're talking about microservices, but in fact microservice is all about distributed computing. So we saw microservices, we saw SOA, we saw Corba, we saw AGBs, we saw RMEs, and so it's the same thing, but going back and forth, but always getting easier for us as developers. Every time that we switch from one solution to another, it's always trying to solve or getting better. That's why I think that in this moment, even using a server-side solution like a service mesh, it's still better than having a bunch of libraries inside your code, or having to implement, as I said before, each language implementing the same solution.
Yeah, this is the worst case, one of the major points. If you have many languages in your cluster, so the first thing that you have to implement same things in different languages, well, this is the first signal that stop it, don't do that. Because you have to support it further and further in different languages, and maybe you have developed everything, and now just to support it, you have to keep all this knowledge of different languages and other things. Well, it's not good from control point of view of the solution. But for example, for me, you wanted to say something?
Yeah, I just wanted to ask the audience, is anybody here using microservices already? Okay, so more than half. And who here has different languages in his microservices?
I do.
Less, much less. Okay, thanks.
Yeah. So the question I wanted to ask is, Well, let's consider me as a starter developer in service mesh. And I want to start from something. Is there an advice or a solution you would say that start here if you want to start playing with service mesh at home, for example, for learning that thing? Do you have any advices for that?
Yeah, it's true. I mean, right now is the standard for playing. As you said, production ready, I'm not sure, but it's standard for playing. It's very easily, you can install it easily on Kubernetes. So yeah, it's fun. You can play with it, and then you can try to check every feature that it gives you. Like it's not only about circuit breaker, but you can also have like traffic mirroring, A/B testing, this kind of stuff. And perhaps, yeah, then it can give you ideas that right now you cannot implement because it would be too hard in your current infrastructure, and how it can help you solve business cases and stuff like that.
So it's kind of just going to the website, downloading the Docker image, starting it on your computer and deploying there something.
It's more like installing Minikube and then getting the YAML file from Istio, which are like 4 or 5 different files that you need to just execute, apply.
But doesn't it mean that we say that we split development and DevOps like 50-50 approximately? But again, doesn't it mean that each developer to start play with that should now learn DevOps part? Should I have to learn Kubernetes, how to play with it?
The first is, you cannot say you have dev on one part and DevOps on the other side. This DevOps word is misused most of the time. So before we had dev on one side, ops on the other side. They had different objectives, different goals, different metrics, and they didn't collaborate. The fact that people are now recruiting DevOps is just fucked up. They don't understand that. DevOps is just the fact that dev and ops should collaborate. They should have common goals. They should have common metrics. So you don't recruit DevOps. A DevOps guy doesn't exist. You can practice DevOps inside your organization. The rest is just crap.
I really would like to highlight that, like with a bold underline, that this is one of the key points. Most developers really consider that I'm a dev and those are DevOps, and when an issue arises, oh, DevOps have fucked up this, or vice versa, DevOps say, oh, go and fix your code. So really there are no two boards with different people on board. There is only one board. And everybody is on board. And service mesh really comes even closer to that if you don't work together with everyone as a team, then you have messed everything. And service mesh really gives that idea a more power up, like if you don't do things together, yeah. And by saying together, I mean what you said, highlighting that really there is no different kind of people. So you do not have to learn something new, but just get more knowledge about this kind of solution as a new option in your pocket, and decide where you want to use it or not. So this is the idea.
When I was younger, I mean, when you developed Java EE apps, you only cared about the war or the ER area that you created, and after getting more experience, you started getting into how an application server worked and how you could configure one. And I mean, that was already DevOps, because that was not part of my job, but I wanted to learn about it because, I mean, also the guys would be, the ops guy would be happy to learn about how managing stack trace and how, I mean, and that's collaboration. Now, Kubernetes and Istio and all this stuff can make that the common language between dev and ops. And
so that means we should kill the position called DevOps. There should not be a position like that.
It doesn't exist, really. Who here has a DevOps position? Yeah. Who here is DevOps?
Yes.
Now they are all afraid because they know that they will beat you a lot.
Don't be afraid, we will write down your names.
Who here has a DevOps position inside a company, like official title DevOps guy?
We have one here.
And are you on the...
Because we work in the same company.
That's not my fault.
He's DevOps, and this is why he's
I'm not DevOps, but we have DevOps position in our company.
And what does that mean in your company?
In my company, that's mean ops guys. So they just call it DevOps because everybody on the market thinks it's DevOps.
Yeah, that's the issue actually. I've noticed that as well. So basically you have the ops guy, you put dev in front of it, and that makes him the DevOps. That's very easy, but it doesn't change the organization. But you can have the same with Agile. Huh? You put everyone in a circle every morning, and now you are Agile. Really? You don't do it? No? Yeah, you do it, but you still have a project manager. Now you call him a Scrum Master, but yeah, and you are Agile. It's the same stuff, in my opinion.
Yeah, that's true.
It is just, yeah.
Yeah, I also want to add about, it's related to the client-side patterns that you said, that even if we have service mesh, it doesn't mean that developers should not care about the application, how it behaves, is it fault tolerance, does it send metrics and stuff like this. So service mesh, it just like allows you to have some consistency between your microservices, but still you have to care about it as a developer. So it's not like just ops responsibility.
This is those bunch of things that you had to learn to develop microservices with Java tools, for example, with Netflix or other things we have in Spring and other frameworks. But now let's say, just because of there is a service mesh, it doesn't matter. It doesn't mean that you don't have to learn all this stuff because a DevOps guy will do this. Then you
actually you have to learn both because both have pros and cons. Come to my talk to learn more.
Yeah, because
sorry, shameless plug.
Patterns are same. Knowledge is just even more. You have to learn here, but this is kind of. Do you want to be better? I would say this is that way for me. If you want to be better developer, then this is not something alien to you. It is not a separate DevOps position who should handle it. It is again your work. You have to know this to understand how your solution finally works, to understand the whole architecture. So it's not a separate solution. It's not something new. It's just a continuation of the evolution of, call it microservices. So like, from evolution stepwise, you remind me the Java Enterprise. We had big servers with different modules we called enterprise beans and other blah blah blah, which we deployed there. Then we removed bigger service, and each module started working as a separate application with a smaller application server inside it. After that, we introduced things like serverless, other stuff, like we made even those business logic functions smaller, call it data microservices or other smart words. Again, those were that modules, pieces of code that worked more in a more distributed fashion, and we had many of network related activities. And service mesh is next step here, that's how we solve common network related things, even maybe a little bit more. You can add, guys, more payload of information here. But now, so it's kind of the whole architecture called in a single word, in a single phrase, how things should be done. So even if you don't play with service mesh, you already know it, or you have to learn it. So if you don't want to play with a solution like Istio or anything else, it doesn't mean that you do not have to learn those patterns, standard solutions that solve these issues. So it's again the same thing. Just go on with learning, and this is the place where you have all these standard solutions in one place. And one of the right ways, what is considered now the right way to solve those issues. So I would say it's more kind of, do you want to be better? Then start looking into service mesh. Because maybe it's not the future, but it's the present for now, where we have to deal with that. And from today to tomorrow or the next days, weeks and months, you will have more service mesh solutions coming into your companies, your projects. So you have to deal with that. Go into that, play with it, ask questions, and start learning what is it, what it solves, and why do we need it. So it's like that for me. Do you want to add something?
Who has Minikube installed on his laptop, personal laptop here? Few hands. Or alternative to Minikube, whatever? Okay. Okay.
Install in Docker for Mac, for example, or is it Kubernetes?
As the other, you know what you have to do, right?
We have last minutes. Maybe would you like to add something for guys?
No, I think
It had a few minutes.
Yeah, I think that you made a very good point, so I don't have anything else to complement. But related to the DevOps discussion, I know that it sounds like something that's repeatable, but the DevOps is about it's about breaking the silos. It's every DevOps conference that you might go, or any DevOps reading will mention that. It's about breaking the silos. So it's not. It shouldn't be, as Nicolas said, it shouldn't be a position. It should be. When I learned, when I heard about DevOps, and I was trying to figure out what it was, and I figured out that it's only about a bunch of practices that or works on the culture side to avoid having those silos. For example, if usually developers commit your code on Friday 5 or 6 p.m. and just say bye, I'm going home, and the admin stays there the whole weekend. He doesn't know how to read the stack trace, and then on Monday he says, okay, I work it, the application is there, but it's failing. So DevOps should be something should be a collection of practices, not should be a position. That's what I would complement in this discussion. Anything at all to add?
If you want to go the full DevOps way, the only way is you build it, you run it. Because the guys who make the bug, who introduces it, is the one you should get called at 2 a.m. in the morning to fix it. That's really DevOps, actually. That's what you want to achieve. If you know that if you introduce a bug, you will be called at 2 a.m., you will be very careful because before writing one line of code.
By the way, I have a really funny story about that. I worked in a company where a new manager arrived and he was worried because of what I said. Developers went home on Friday, and usually every weekend there was a problem. So he said, okay, developers should be here during the implementation. During the deployment process. That happened one weekend, 2 weekends, but it stopped on the third weekend. So they decided to work together with the admin to implement and avoid any outage at nights or weekends.
It's like your final target as a developer is that shit should work.
Yeah.
It's not about I have coded, I have deployed. It should be working. If it's not working, then you have not completed your job.
That's true. That's true.
Because you are not paid for bugs, you are paid for result, working result.
And actually, the older I get, the more I realize that we are all about technical stuff and using the latest trend and whatever, but a lot of problems that happen are due to organizational or personal or human problems. And this is not related to any technical issue at all.
Any questions, guys? Okay, so the time is up. Do you want to add something, final word?
Prijetного apetita.
Okay, thank you.